Continuing on with our coordinate geometry topic, this lesson we'll be focusing around using a few skills that we've learnt previously and trying to combine them all together and getting stuck into what geometry is actually all about. So up on the screen now there are a few points or key hints and tricks that we've picked up along the way that are going to be useful in this lesson. So the first two is just when we have two gradients, we label them as M1 and M2. Stemming off from that yellow box there, we've got two more, and we state that if two gradients are parallel, they equal each other, or we have this kind of hard looking rule here for finding perpendicular gradients, but basically we know this rule as the whole flip and reverse the sign. So if we've got a gradient of a half, we flip it into a 2, make it negative, and there's the perpendicular gradient. The other fact that we've just learnt in the last lesson is our point gradient form. It is probably the most useful formula you will ever come across in linear equations. It is the most versatile and flexible rule. You can find any linear equation by just having a point and a gradient, all of which can be found by either looking at graphs or being given information. So that's the best one. That's the one we're going to be using the most of. So jumping into some examples. We are asked to find the equation of the line parallel to this point here. So we have those two bits of key information and it passes through the point 2, -7. So that's straight up. 2, -7 is useful information. Now remembering back to our point gradient form, y minus y1 equals m outside of x minus x1. For that we need a gradient and we need a point. Now we already have our point, it's here. It is the 2, -7. However, we don't exactly have the gradient just yet, but we do have enough information to find it. We know that we have our linear equation here, and our gradient is parallel to that one. So at the moment, we don't know what the gradient could be. We need to rearrange this general form equation so that we have our gradient intercept form, where y is on its own, and everything else is on the other side of the equal sign. So let's do that now. We have -2y plus 8x plus 4 equals 0. Now the first thing we need in gradient intercept form is our y to be positive. At the moment our y is negative, so it's going to be more beneficial for us to not move everything else and deal with the negative sign, but just by moving a -2y across by adding it, we kill two birds in one stone. We make our y positive and we separate the y from everything else over an equal sign. So we're going to be left with 8x plus 4 equals 2y. Now our gradient intercept form, remember that one as y equals mx plus b. So y needs to be on its own. It's not allowed to have this multiplied by 2. So what we're going to do to move it to the other side is we're going to divide by that 2. Now we're going to have 8x plus 4 all divided by 2 equals y. Now remember, when we have a whole expression that shares a denominator, we can split that denominator up to be under each term. So we'll have 8x divide 2 plus 4 divide 2, which equals y. Cleaning this answer up a bit, we have y equals 4x plus 2. Now in that form, we can clearly see that our gradient is 4. The original question asked us to find the equation, so what we're going to do is use our point gradient form to find this linear equation by using all the bits of information we know. So the equation is y minus y1. Now y1 from our original question is the -7. That is equal to the gradient down here in our green circle, which is 4, outside of x minus x1, and x1 was written in the question as 2. Now going ahead, cleaning up this little equation, we're going to expand the brackets by multiplying everything in the brackets by the 4. So 4 times x gave us 4x, and 4 times -2 gave us -8. And over on the left side we still have y minus -7. Now remembering, if we have minus a negative number, we can override that as just a big plus. And the way we're going to move our 7 onto the other side is by taking it away. So we're going to have y equals 4x minus 8 minus another 7. So it's 4x minus 15. And there is our linear equation that fits all the information originally given to us in the question. Okay, moving on to the next example. In this one, we're asked to find the equation of the line perpendicular to an equation. So there's a key bit of information, there's a key bit of information, which passes through the midpoint between these 2 points here. So as you can see, this is exactly the same as the last question, but it's stepping up the level of difficulty because you need to, first of all, rearrange that general form equation so that we can pull the gradient from it. Then we need to grab that gradient and find the perpendicular gradient. After we've done all that, we then need to find the midpoint between 2 points, and finally we can join all that information together to get us our answer. So a lot of work is going to be needed to solve this question. So first off, we're going to need y equals mx plus b. This form can tell us a gradient just by looking at the number before the x, and we have an equation to start with, so we're going to need to make our general form equation look like our gradient intercept form. So let's go ahead and rearrange that. We have negative 5x plus 3y plus 4 equals 0. Now, having a look at our equation up the top here of gradient intercept, our y is positive, and we have a positive 3y, so what we're going to do is move everything else onto the other side of the equal sign. So we have a minus 5x, so we're going to move that over by adding it, and we have a plus 4, so we're going to move that over by taking it away. So we have 3y left on this side. We added the 5x, so it's now positive, but we took away the 4, so now we have a minus 4. Again, noticing our original form up here, our y is on its own, there's no 3 or anything attached to it, so we need to move that on the other side. We're going to do that by dividing. So we're going to be left with y equals 5 over 3x minus 4 over 3. Now from this equation, we only need to pull out the gradient. Our gradient of 5 over 3. That's not quite the end just yet. We need to rearrange that gradient so that we have the perpendicular gradient to that one. So we're going to label that one as m1. m2 is going to be that gradient flipped. So instead of 5 over 3, it is now 3 over 5. And because our original gradient was positive, this one needs to be negative. So this is the gradient we need to use in our answer when we get there. But also for our answer, we need a point. And we have some information to find a point, but we don't have the actual point. So we're going to go ahead and solve that. Now midpoint, remember, your midpoint is a point itself. Now remember, it is found by finding the middle of each x and y coordinates. So here we're going to go ahead and sub them in. x1 is 18 plus x2 of negative 6, and then we've got to halve it. Big comma. Then our y values of negative 4 plus negative 10. Add those together, halve it, and put brackets around to show that we're talking about a coordinate. Now 18 plus a negative 6 is 12 over 2, and negative 4 minus a 10 is minus 14, still over 2. Halving each of those values, we get 6 and negative 7. There's our point. Over on the left in blue is our gradient. So we need to put this all together in our point gradient form. Remember, it's y minus y1 equals m outside of x minus x1. Subbing in our values, y minus negative 7 again, with our gradient of negative 3 over 5 outside of x minus our x point of 6. Cleaning this up a bit, we have a y plus a 7 on this side, negative 3 over 5x, plus, because a negative times a negative gives us a positive, 3 times 6 is 18 over 5. Then we need to move this 7 on the other side by taking it away, doing the opposite of what it's got at the moment. We will be left with y equals negative 3 over 5x, which will give us negative 17 over 5. Now, if you'd like, you could clean that up to be negative 3x minus 17 all over 5, but again, that's just a final aesthetic step. I prefer this one here because it's more informative. Okay, that's example 2 done. Moving on to our last example, we have what would be typically recognized as a true geometry question, in that you are told a bunch of information, you're given a picture, and you're asked to work things out with no real direction about how to actually get there. So over here on our right we have a little parallelogram made up of 4 points, 4 coordinates on a graph, and we're asked to find a whole lot of equations of the lines that are over there. We're asked to find an equation of a line that doesn't exist just yet, and then we're asked to work out some missing coordinates. So what we're going to do is have a look at first part A, find the equation of the side PQ. So here is point P in blue and point Q. Working out the equation of a line, we need either to solve our gradient intercept form, we need the y-intercept and the gradient, but we're not really given a graph with any kind of scale on it, so it's extremely inaccurate to try and read off a y-intercept on there. So our other way is using the way we've just learnt, that one formula that will solve all your problems, the point gradient form, y minus y1 equals m outside of x minus x1. So filling in some bits of information, we can use either point P or point Q because they're both on the line that we're looking for. For me, I'm going to use point Q because it's a couple of positive numbers and I like dealing with positive numbers. So I'm going to have y minus our y1 value of 3 equal our gradient. Now remember, gradient is rise over run. So our rise is 3 minus 1. You get your qy value and minus your py value. That tells you how far your graph has risen. And to know how far your graph has run, you get your qx value and you minus your px value. So that's y2 minus y1 divided by x2 minus x1, or rise over run. And then you multiply that by x, take away my x1 point, because I picked q, that is 2. Cleaning this up, y minus 3 equals, now 3 minus 1 is 2, divided by 2 minus negative 6, so I add those and I get 8 outside of x minus 2. Continuing with getting rid of brackets and the like, I need to multiply my gradient by both term inside the brackets. Now my gradient could be 2 over 8, but I see that as 1 over 4, so multiplying that by x, I'm going to have x over 4 minus 2 multiplied by 1 over 4, which is 2 quarters. Cleaning it up again, y minus 3 equals x over 4 minus 1 half. Now I need to move my 3 across. It's take away 3, so I'm going to add it, which will give me y equals x over 4 plus, now that's 2.5, so I could either write that as 2.5, or because my x value is already a fraction of x on 4, I would prefer to leave it as a fraction itself as well, which would be 5 over 2. So there is the equation of the line P to Q. Now B and C are again the same kind of question. You would solve them in the exact same way. What I'm going to do is I'm going to work through them rather quickly and not do the full steps like I just did. So with point B, I'm going to need my gradient. Now I'm going from P to R, so I'm going along that little box there. Now very quickly, looking at the rise of this graph, I'm going from a 1 to a negative 1, so my rise is going to be 2. My line is going down, so I know it's a negative gradient. My run, I'm going from a negative 6 to a negative 2, so I know my run is going to be a 4, which is going to give me negative a half. Picking any one of my points, I'm going to pick smaller numbers because they're easier to deal with, so I'm going to go with negative 2, negative 1. Using the point gradient form, y minus y1 equals m outside of x minus x1. subbing in my values, I have y minus -1 equals my gradient of -1/2 outside of x minus my x value of -2. Cleaning all this up, I have y plus 1 equals -x on 2 minus 1. I need to move my 1 across. I'm going to do that by taking it away. So I have y equals -x on 2 minus 2. And there is our equation of P to R. Now, solving the equation of the side R to T, you could do it the same way. You could draw your little triangle on and try and work out the rise and the run, but extremely difficult to do when you don't have the coordinate. However, what you do have is the side R to T is parallel with the side P to Q. So you know the gradient straight away. It is the gradient we worked out in our part A, which came out at 1/4. And you know one point on the line R to T because you know the point R. So what we're going to do is give myself some more room. We're going to be answering part C. Our gradient is the same as the line of P to Q, which came out at 1/4. Our point on the line, so our x1, y1 value, has to be a point R or point T. Because we don't have point T, all we have is point R, so we need to use -2, -1. And we're going to use that information, put it all together in our formula of y minus y1 equals m outside of x minus x1. We will have y minus a -1 equals our gradient of 1/4 outside of x minus a -2. Cleaning this up, y plus 1 equals x over 4 plus 2 over 4. Moving our 1 across by taking it away, we still have an x on 4 plus 1/2 minus 1 leaves you with -1/2. And there is our equation of the line RT. So by any means no more difficult. However, if you did want to use the same method we had just employed and try and use this coordinate of t, it would have been extremely difficult. Now, part D, find the equation of the diagonal Q to R and show that it cuts the y-axis at 0, 1. So what I'm going to do is get rid of all our stuff we've written over here. It's going to start to become a little more confusing. And what we're going to do is draw on our line of Q to R. That's what we're trying to find there. We're trying to find that equation. Once again, it works in the same way. We still need the gradient. We still need one of those points. We can pick any one we want, and then we go ahead and work out the actual equation using our point gradient form of a linear equation. So having a look at this graph, you can use your rise over run, which comes out as y2 minus y1 over x2 minus x1. That will give you your gradient. You can sub in the points that you need and that'll come out, but we have a picture, so I'm just going to go straight ahead and use my picture and say my rise, my graph went from -1 to 3, so it rose 4, and my run, it went from -2 to 2, so it did a run of 4 as well. And when I sub those in and have rise divided by run, I'm left with a gradient of 1, and I'm going to use my point Q of 2, 3 purely because I like dealing with positives. And it didn't matter if I picked Q or R because they're both on the line we're trying to find. So moving down here, answering part D, our gradient was 1 and our XY values came in at 2, 3. Using that to sub into our point gradient form, y minus y1 equals m outside of x minus x1. Y minus a 3 equals a gradient of 1 outside of x minus a 2. y minus 3 equals, now expanding the brackets, we're multiplying everything inside by 1, which doesn't change anything, so we're left with x minus 2. Moving our 3 away from the y, we do that by adding it, so we're left with y equals x plus 1. There is the equation of our line. Now if you remember, there was a second part to this question D that said show that it cuts the y-axis at 0, 1. Now when a line cuts a y-axis, we're talking about its y-intercept. So if we scroll down, have a look at our form of our equation. It's in gradient intercept form. Remember, the number before our x is the gradient, the number on its own is the y-intercept. Our y-intercept is 1, which means that our y-intercept is at 0, 1. When you're on the y-axis, your x value is 0 and our y value is 1, so we just shown that it cut the y-axis at 0, 1. Okay, last question. Find the coordinates of t. Now once again, I'm going to clear our stuff away so we have a nice picture to start using again. We're trying to look for the coordinates of t. Now it sounds difficult when I first approach this, but all we need to do is realize that these two lines here are parallel, so they share the same gradient. So what I'm going to do is I'm going to work out the gradient of our line P to Q, which was from our original question in part A, 1 over 4, or 2 over 8 more specifically. And I'm going to apply that to our point R and T. Because they're parallel, they should come out at exactly the same place. So the rise over here, it went from 1 to 3, so it rose 2. It went from -6 to 2, so it ran 8. So we should have the same things happening over here on the other side. So if we're going to start at -1 and we're going to rise 2, we're going to be at a y value of 1. If we're going to start at -2 and we're going to run 8, that means we're going to be at a +6. And that's all there is to it, to answering where is point T. It is at 6, 1. Okay, thank you for your time. I hope you enjoyed this video, and good luck.